Hey, we're live. We'll go like that. Chapter 3, compounds, last chemistry topic. So I think, Nicole, you could make an argument that the course gets easier. Lindsay, what did you find? After chemistry, did the course get less abstract, easier, or say yes? Support your teacher. Thank you. There you go. Look at that. You're on YouTube now. Woohoo! Okay. What are compounds? Again, if the periodic table, which you probably want to have out and in front of you, just a hint, if the periodic table is the alphabet, compounds are simple words, although you can also get up to hugely complicated words. There are compounds that literally are millions of of atoms long. Those are made in labs. A lot of the weird plasticky ones are crazy long formulas and have neat properties. But we're going to start off fairly simple. What's a compound? Well, a compound is formed when two or more atoms are joined together through, here's the word you can fill in, chemical bonds. And this year, there's going to be two main types of chemical bonds. We're going to be talking about that today. There's going to be two main ways that a calcium atom can join together with a chlorine atom, or a oxygen atom can join together with a chlorine atom. Examples: water. Water is H2O. H2O is the chemical formula, and we'll call it that, for water. What do you think the numbers and the letters in the formula mean? What do you think the H stands for? Hydrogen. What do you think the O stands for? What does the 2 stand for? I'm going to give you a hint. It either tells you how many oxygens you need or how many hydrogens you need. Tells you how many hydrogens. So you have to kind of guess. You haven't learned yet. So what do you think the numbers and letters in the formula mean? Well, H is for hydrogen. You can fill that in. O is for oxygen. And the 2 means that there are 2 atoms of hydrogen. The 2 means that there are 2, I guess I underlined the word 2. That's what I wanted you to fill in. Atoms of hydrogen. By the way, there is how many atoms of oxygen? Just 1, but we don't write the 1. We don't write this, H2O1. Much like in math, when there's a 1 in front of an X, we don't bother writing it. We just say, yeah, it's there. Okay? So far, so good. How are elements joined? This is the important part of this. And so I want you to imagine that there are 2 kids and they're playing with a truck in a sandbox. What are the 2 main ways that they could interact with that toy truck? There are 2 words. And this, depending on which one you think of first, tells me a lot about your personality. The first word is mine! And that would lead to conflict and argument. But that's you can't play with my truck. What would a better way to play be? Share. It turns out you can use that analogy to talk again about how chemicals bond. One way they can bond is to steal electrons from each other. Mine! Another way they can bond is to share electrons with each other. Atoms are just like kids in our analogy. Remember, we said this. Atoms want to have a full outer or valence shell. And there are 2 ways they can get that. Share or mine. They can share electrons with other atoms. So the key word there is share. We call this a covalent bond. You're going to need to know this word, covalent. So put a star next to it, underline, and we'll be flogging it, talking about it like crazy. But here's what I want you to notice. Amelia, what are the first two letters of the word covalent? Here's what I remember, and you can write this down as a hint next to this. Cooperate, covalent, share. That's my covalent. Do we share electrons or do we take electrons? Covalent, cooperate, share. Oh, and you can kind of figure out what the word means because valent would mean outer electrons. They share their outer electrons. The inner ones are locked inside the shells, but that outer shell, Jordan, is accessible, and we share. The other way that they can do it is they can steal or lose electrons. We call this an ionic bond. What one-syllable word did I use for this particular situation? So I said share. What was the other option? One-syllable word. What did I come up with? Mine, right? Here's what I think. Ionic. If you're looking for a stupid way to keep these straight, when I see ionic, what's the first letter of the word what's the first letter of the word ionic? No, the first letter of the word ionic. It's all about me. I want it. There's different ways you can come up with to remember this, Riley, but ionic, either the atom doesn't want the truck, it gets rid of its electrons, its outer shell electrons totally, or the atom wants them all and is going to hoard them, but it's no cooperation, no share. Ionic bonds are not as strong. Covalent bonds are very strong. In fact, they're so strong that often when you break those bonds, energy is released. Most explosives are covalent bonds, and the explosion is actually, Nicole, breaking those bonds, and they're so reluctant to break, they give off energy because there's so much energy packed in there. So, covalent bonds, always between nonmetals. Hey, what are the nonmetals on your periodic table? You know, you don't actually have to have that memorized, Kiana. It does say on the periodic table at the top, right? Isn't there little metals pointing that way? Sorry, nonmetals pointing that way and a metals pointing that way near the top? Give me a little nod. Yeah, okay. So, as I've said time and time, and I'll say it again, Pierce, you don't have to memorize the periodic table. You do have to understand it. So, covalent bonds, could you form a covalent bond with magnesium? Taya, you're shaking your head. Why? It's a metal. It will never form a covalent bond. It will never share electrons. It never will. Could you form a covalent bond between oxygen and fluorine? Yes. Could you form a covalent bond between oxygen and gold? Nope. In fact, our rule is going to be this. If you see a chemical formula and it has a metal, it's not covalent. It's ionic. So in a covalent bond, the electrons, by the way, you can write the word electrons, or do we have a handy dandy little symbol for electrons? You can put E negative, are shared. So one or more electrons is kind of doing double duty. It's keeping both atoms happy. It's allowing the valence shell of two atoms to be full. And once you've got that, turn the page. So here's a picture. Water. Chemical formula. What was the chemical formula for water? Remember it? H2O. look at the picture. Can you see two of one thing and one of another thing? So can you reason out which one's the oxygen and which one's the hydrogen? You could also figure it out by their valence shells. So hydrogen, where is it on the periodic table? Element number what? How many protons? 1. How many electrons does it normally have? Just 1. How many would it like to have in its valence shell? 2. So from hydrogen, that's, you know what? I can make that a little bit brighter because that's on blue. I'll go big red. That's a hydrogen electron, and that's a hydrogen electron. The instructions say put an O next to the electrons from oxygen, put an H next to electrons from hydrogen. So I say it's those two, or it could be these top two, but I'm telling you, these ones up here are not the ones from hydrogen. How many electrons does oxygen have in its valence shell? Count from the left. 6, right? If you count from the left, 6. Total of 8, but I don't care about the inner shell. So there's its 2 inner ones. Those are locked inside, can't be played, can't be accessed, so I'm not going to freak out about that. Can you see 1, 2, 3, 4, 5, 6? Let's put an O on each of those. 1, 2, 3, 4, 5, 6. But can you see now, Rihanna, if oxygen shares with hydrogen, how many electrons does oxygen have in that valence shell if I count all of them? How many? Count around. In the valence shell, outer shell. Ready? Rihanna, count with me. How many does oxygen want in its valence shell? 8. Is oxygen happy? Yeah. How many does hydrogen have in its valence shell? 2. How many does it want? 2. This is a covalent bond. Okay? And you can see why you need 2 hydrogens. If we didn't have this guy, does oxygen have a full valence shell? So will this be a stable compound? No, it's still hungry. It still wants the electron balance. Try HF. Okay. We're going to try and draw a picture of HF. What? You guys got room there, yeah? You ready? We're going to draw it together. Let's put H on the left. So, yunk. And hydrogen only has 1 valence shell. Where's fluorine? What element number is it? 9. What row, what period is it in? First row, second row, third row, fourth row. Period 2, I'm going to ask you the same question. How many shells will it have? 2. So you ready? There's its nucleus. There's its inner shell. And now I'm going to overlap. Yonk. There's its outer shell. Oh, you want it overlapping because they're sharing. Otherwise, if they're not touching, they can't be sharing. Now, fluorine has 1, 2 on its inner shell, so put those 2. And you're going to figure out pretty quickly, Candace, that all the action happens in the valence shell. In fact, in grade 10, we'll show you something called the Lewis diagram, which works better. It doesn't even care about the inner electrons. All you care about is the valence shell, and they're less writing and they're kind of nicer. How many electrons does fluorine have in its valence shell? So find fluorine, count over from the left. How many? 7. So you ready? 1, 2, 3, 4, pair 5, pair 6, pair 7. There's a fluorine atom, and this right now, as I've drawn it, is not stable. Why? It has 7 electrons. How many does it want? Now let's go look at hydrogen. Hydrogen, what row is it in? First period, which is why I only drew, Kiana, 1 shell. How many electrons does hydrogen have? Just 1? I'll do it in red right there. But by setting it up this way, can you see, Lena, how many electrons does hydrogen now have in its valence shell? 2. Now it's happy. And how many electrons does fluorine have in its valence shell? Now it's happy. We give this a special name. You can write this next to it. We call this compound, Lindsay, what do we call HF? The IDE rule, we call it hydrogen fluoride. The rule you're going to learn when two compounds are joined, the nonmetal, the last nonmetal, we add the word "ide" to the end of it instead of "ene" or whatever it's called. Let's try a tougher one. By the way, how many hydrogens were there in this particular compound? 1. How many fluorines? 1. How could you tell? Because technically there was an invisible 1 there and an invisible 1 there. Try another one. How many silicons are there in this particular? Okay. Now, I should have asked, how many oxygens? 2. 2 oxygens, see it? 1 silicon. I should have said one more thing. I should have said, is this ionic or covalent? Here's how you can tell. Let's go back to this one. Are any of these metals? Then it's covalent. Are any of these metals? Silicon is a weird one. It's on the right side. It's a nonmetal. Okay. How many silicons? 1. How many oxygens? So the way we're going to set this up, don't write this down. I'm just going to give you the rough sketch. I'm going to put the silicon right here. I'm going to put an oxygen here and an oxygen there with silicon in the middle. Does that make sense, Nicole? That's the only way I can kind of fit it together, Nicole, okay? So let's draw the silicon first. What row is silicon in? What period is it in? Hudson, you're right. I think you were right. Countdown. I thought, or was it Mateo? Someone over there said it right. From third. Third. How many shells will it have then? I only care about the outer one, but ready? So here is, we'll even put an SI in the nucleus. It's got 1, 2, 3 shells. Right? Let's fill in the inner shells because they're boring. 2. Then how many? 1, 2, 3, 4, 5, 6, 7, 8. I'll come back to that outer shell in a second. I'll come back to that outer shell in a second. Oxygen. Let's put 1 oxygen right there. Let's put 1 oxygen right there. That's an O. That middle circle, that tiny circle is an O, not a nucleus. How many shells does oxygen have? What row is oxygen in? Row 2. So it's going to have, you know what? I'll change colors for you just to make it, I'll go black for oxygen. Can you put it on the other side? Put what on the, I don't know what you mean. It's going to be on both. There's going to be an oxygen atom on it because I have to fit 2. How many oxygen atoms, Mateo? Can you see it? There's going to be 1 here and 1 here. It's going to be kind of like a little Mickey Mouse molecule when all said and done, I think. Here's the inner shell. 2. 2. Now this tells you how bad my drawing is, but I'm not going to take marks off for lousy drawings. The next shell needs to overlap with silicons. I'm going to draw it like this. I know that's not even. Shut up. Okay? So, are you ready? How many electrons extra does oxygen need to be happy? 2. So I'm going to do this. There's going to be from silicon 1 there and 1 there, and then oxygen has 1, 2, 3, 4, 5, 6. We may have to do some adjusting here. We'll see. How many electrons does oxygen need? 2. So again, I'm going to go 1, 2, and then oxygen has on its own 1, 2, 3, 4, 5, 6. How many electrons does silicon have normally if you count from the left? If you count from the left, 1, 2, 3, isn't it 4? Find silicon. 4? How many blue dots have I drawn in my outer shell already? Uh-oh. What's the problem? Ooh. What the ooh? How many electrons do I want to get for silicon? 8. Now I got a problem here because I can't magically just add electrons. Do I have 6 black electrons for each oxygen outer shell? Yeah. Do I have 4 blue electrons for the outer shell of silicon? Okay, so, well, this is where, remember I've told you most of what I've showed you is technically wrong. What's going to happen is the shells, the electrons, they're going to bend, they're going to warp a little bit. Here's what I want you to do. Cross out that one, cross out that one. It's actually also going to end up over here and over here. Cross out this one, cross out this one. It's actually also going to end up over here and over here. Now let's check. Does this work? How many black outer electrons do I have? 6 in each oxygen, so I haven't changed oxygen. But how many dots does oxygen have in its outer shell if I go all the way around? Does it have a full 8? 2 blue, 6 black. What about silicon? 4 blue, 4 black. This is a model. In real life, it doesn't look like this either. But this at least lets us see how it's possible for all the electrons to be shared and get a full valence shell. Is that okay? Those are covalent bonds. Turn the page. Ionic bonds, all about me, all about I. This is how you can actually tell what it is. An ionic bond is always going to be metal first and non-metal second. At least this year. Again, Lyndon, like I'm telling, everything's a lie, but at least this year. So whenever you see a chemical formula, the first question you should start asking yourself right away is ionic or covalent? And how do you know? Metal, ionic, non-metal, covalent. So let's identify each of the, we're just going to do this together. I didn't include it in your notes, just look up. Identify each of the following compounds as ionic or covalent. I'm going to skip A for a second. How about I for ionic? What would be a good letter to use for covalent? C. So look at B. What's this? What's the O? What's Cl? Is O a metal? Covalent. What about C? Is Sn a metal? You got to find it. It's not scandium. Okay, Sn is tin, and I know it's a weird one. Sn is tin. Is that a metal? This is ionic. What about D? What's the first chemical you see? Sodium? Metal? It's ionic. What about E? What's the first thing you see? Nitrogen? Metal or non-metal? Covalent. This is why I said, do you have to memorize the periodic table? No, but is it worth knowing your way around so you don't have to look up every single one of these, Damien? Yeah. It's worth knowing your way around. What about S? Sorry? Non-metal? Covalent. What about G? Capital N, what's that? Covalent. What about Fe? What's Fe? Iron. Oh, iron. Metal or non-metal? Ionic. Mr. Dueck, why did you skip A? A, as I've told you, there's always an exception to everything that I'm giving you. This is ionic. I'm not going to tell you why yet. Well, I'll give you a hint. Do you see how this thing is in brackets? That's what's called a polyatomic ion. It's a group of atoms that behaves like a single atom and behaves like a metal. We'll come back to that. But certainly B, C, D, E, F, and G, as far as I'm concerned, are fair game on like a practice quiz or a practice test. Next page. So how does an ionic bond work? One atom steals one or more an electron or electrons. And the other loses. Which ones wanted to lose electrons, metals or nonmetals? Metals. Which ones wanted to gain electrons, metals or nonmetals? Nonmetals. Hey, this is a match made in heaven. You want to get rid of something? I want to take it off your hands. Let's be friends. But in this case, instead of sharing, the electron is completely transferred over to the other ion. As a picture. This is not in your notes, but here's a nice picture. Sodium, well, the notes are in your notes, but not the picture. Sodium has only, you can write the word, one electron in its outer shell. See it right there? Right there. Right here. If it loses it, then its outer shell is full, and it's happy. Chlorine, Cl, needs only one electron to fill its outer shell. It's a match made in heaven. Chlorine steals one electron from sodium. Now, how do we... Did I go down too far, Kiana? Is that better? You got it? So, chlorine steals one electron from sodium. As a picture, it would look like this thing here. And just to color code it for you, if that's the sodium electron, there it is right there. 7 of those outer electrons are from chlorine. 1 electron is from sodium. Oh, and look at sodium's valence shell. How many electrons does sodium have in its outer shell? Not this one here, but in its outer shell. None as a number, 0. It's got a full shell. These are called Bohr diagrams of ion. Oh, we did this on the test. So on the test, we said to draw a Bohr diagram of an ion, you had to list the neutrons and protons, you had to show the valence shell, and then square brackets to show that it was an ion and the valence charge. Let's try a picture. Let's try drawing a picture of LIF. You guys have room there? Yes, on the left-hand side. Now, you might have to take your paper and rotate it 90 degrees so you can draw it like that, or you might be able to fit it like that and like that, whatever. But if you want more room, just spin your paper. Okay? How many lithiums? First of all, looking at this, ionic or covalent, and how do you know? How do you know? Let's write down here. Ionic. How many lithiums are there? 1. How many fluorines are there? Let's just put them side by side. Okay? So you ready? Yep. There's the lithium nucleus. Down here, how many protons does lithium have? Let's write that down here instead of trying to fit it into the nucleus. How many neutrons does lithium have? What row is lithium in? Second row? So, which one? Row 2, period 2. How many electron shells does lithium have when it's an atom? 2. All of us, let's draw this. And let's go 1, 2. And once you've drawn that, put your pencil down. Don't write this next bit down. Normally, lithium has that. I'm going to come back and I'm going to erase that. So don't write that down. Meanwhile, pick your pencils up. Let's start drawing fluorine. So here's fluorine. Just don't draw, Hudson, don't draw that other outer circle because it's going to vanish. Okay? How many protons does fluorine have? 9? How many neutrons does fluorine have? No. 10? What period, sorry, can I stop asking that? Can I just say how many electron shells does it have normally? 2. So there's going to be an inner shell. 1, 2. And there's going to be an outer shell of how many in its outer shell normally? 7. So I'm going to go 1, 2, 3, 4. Yeah, draw this outer 5, 6, 7. Taya, you going to make it? You're a little tired, I know. These are both atoms. They aren't ions yet. Do you know how I can tell by looking at these are atoms? How many protons did we say lithium had? How many electrons did I draw? 3. How many protons did I say fluorine had? 9. How many electrons did I draw? 9. These are atoms. Now, how many does fluorine want to fill its shell? How many does lithium want to get rid of? Oh, I mean, that's a match made in heaven. So this is why I said don't draw this. Here's what's going to happen. This valence shell is going to totally vanish. And where is that electron going to end up? Right there. You don't have to change colors. I'll do that in my notes just so it stands out and you can see where the electrons came from. Now, this left-hand thing, atom or ion, and how can you tell? Why? And how many protons? How many electrons? So it's got a charge. To show that it's an ion, we said square bracket and write the charge. What's its charge if it lost an electron? And yes, you can get this from the periodic table, but I'm also giving you a way that you can figure it out. Plus. What about that right-hand thing? Atom or ion, and how can you tell? How many protons? 9. How many electrons does this particular thing have now? 10. Ion. What's its valence charge? Sorry, what's its ion charge? Negative. By the way, negative what? What number is sitting there? It's invisible. 1. And plus what? 1. What is positive 1 plus negative 1? The fact that the charges cancel out if you add them up tells you this is a stable compound. This compound would exist and be stable. Now, this isn't quite accurate. In real life, look up, there would also be, because this is supposed to be three-dimensional, a lithium ion right here, and behind this guy, and above this guy, and at an angle here, and around every single lithium, there would be a fluoride here, and here, and here, and here. So we're not saying to form this, you need 1 lithium and 1 fluoride. We're saying if you want to combine these, you better have the same number of lithiums and the same number of fluorines. 1 million and 1 million? Sure. 1 trillion and 1 trillion? Sure. But if you have a trillion and a trillion and one, you're going to have one extra. Let's try drawing another one. BeF2. Ionic or covalent? Beryllium, metal or non-metal? That's not really what I'm asking. So find beryllium. Oh, metal? This is ionic. So I'm not going to draw it with the overlapping circles. It's going to be square brackets and kind of chunky. Got it? Right? Beryllium's a metal. It's ionic. Riley, how many berylliums are there? What number is below the beryllium? It's invisible. Below the beryllium. How many berylliums are there? One. How many Fs, how many fluorines are there? So I think to draw this, I'm going to have, don't write this down, a beryllium here, a fluorine here, and a fluorine here, and that's nice and symmetrical. Okay? But let me erase that. Whoop. Here, eraser. Let's do the beryllium first. In the middle. There it is. How many protons does beryllium have? 4 protons. How many neutrons does beryllium have? What period is beryllium in? Okay, so it's in period 2, so it's going to have 2. And then, ready, Mateo? Don't write this next bit down. This outer shell is going to vanish. And you don't have to write it when you're doing your homework. I'm just showing you in the notes how it all fits together. Normally, if it's an atom, how many electrons does beryllium have in the second shell? Count from the left. Count from the left. 2. Okay, so normally, don't write this bit down. It has 1, 2 more. Those are going, don't write those down. They're going to vanish. Let's go work on fluorines. Let's put a fluorine right here and a fluorine right here. What row is fluorine in? Write this down. How many electrons does fluorine have in its valence shell when it's a neutral atom? So it's going to be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. The black stuff, write down, absolutely. Oh, I forgot to do how many protons, how many neutrons does fluorine have? How many protons does fluorine have? So 9p plus, 9p plus, and how many neutrons? 10 n zeros, 10 n zeros. Okay. See the setup here, Casual? Right? How many more does fluorine want? 1. How many does beryllium want to get rid of? Can you see why we have to have 2 fluorines to make this happy? Because beryllium wants to get rid of 2, but fluorine only wants 1. Oh, we need 2 fluorines because they each are going to take 1 apiece. So now it's going to look like this. This is why I said don't draw this shell. One of the beryllium is going to end up there. Electrons, one of the beryllium electrons is going to end up there. By the way, Rihanna, the electron could go here or here or here or here or here or anywhere. And again, you don't have to color code them. I'm doing that just to help it stand out in the notes. Are these ions? How do you know? Protons and electrons don't what? Don't match. How do I show that it's an ion? And the ion charge, -2 plus negative. What's a quick way to check to see if this is stable? If you add across negative plus 2 plus negative, what do you get? Neutral. You've satisfied everything. Okay? I'm absolutely on your test going to ask you to draw some Bohr diagrams of ionic compounds like this. Before you turn the page, or what you've turned the page, before I turn the page, what's the rule? I always put the one that there's the fewest of in the middle, and I surround it with the other ones. What if there was 3? I would probably put one there, and one above, or one below. An ionic lattice. We think of and write ionic compounds in lowest terms, but in reality they are found as a network. So we think and write ionic compounds in lowest terms, but in reality they're found as a network, and here's our word of the day, called an ionic lattice. So remember we did sodium chloride? Really, three-dimensionally, that's more what it looks like if you were to zoom in on the molecule. You'd see chlorines and sodiums all interspersed in a very, very regular pattern, often a crystal pattern, forming a crystal. Because it's three-dimensional in real life. Okay? Put your pencils down.